I want to believe if I
the line is breaking. No, it's just cracking. I believe we are trying Etisalat today, but let's see. It's still breaking. So we hear some, we don't hear some of the things you are saying.
Okay. How about now, sir?
Yeah, we are hearing you. We are actually hearing you, but it's cracking sometimes. So, but let's continue. I believe it will be better as we go on.
Yes, sir. So, Ed, what did because I could just quickly go over the installation again. And this time around, we'll be recording, so everybody will be able to have a glimpse of what entails. Once again, you're all welcome, and we'll be following the installation and that is depending on what we really want. So, all here is can you hear me, sir?
Yeah, we are seeing what is there, but we are not hearing. If you've been talking, at least I'm not hearing. You've been talking. You can put it on slideshow. Like it can be bigger than this. Can you take it the presentation to slideshow?
Can you hear me now, sir?
Yes, I'm hearing you. I'm hearing you say, "Can you hear me?" But if you said anything before then, I can't hear. Well, can you put it on slideshow? The presentation. Yes. Like can be bigger. Yeah. Thank you.
So, are we already?
Yeah. I think so. I believe so.
So again, I'll be going through the understand, and you are welcome to us. So I really recommend lectures. We'll be going over the revising yesterday. Then we'll be look at some mathematical programming technique. There will be learned yesterday. So, and if you have any questions at the end next initial class, I'll be taking the questions. That's for about 40 minutes about for questions and interaction. So we discussed and we said that the MATLAB is tool used to perform mathematical and mathematical calculations, or maybe if you call it, anybody can use MATLAB, even from the biology to the forensic scientists, to the financial experts in financial firms, to understand the different people can use MATLAB. And the version I'm actually using is not the latest version, but it's 20, according to what I covered yesterday. So, in that case, I would advise that probably in time to use Octave. Octave is free and it's available for use and it's available. So Octave as well, a programming language like MATLAB, and I'd like to stress it at this point that both MATLAB and Octave are high-level programming. So, we have two-level programming languages, we have high-level programming languages. Sometimes we have that may be true, but we have basically low level and high level. Now, MATLAB falls under the category of that is why sometimes you may hear in some places where they not really regard MATLAB as a traditional programming software. C++ or Python or JavaScript may be considered a programming language. Be that as it may, it's still programming more like Octave too. Now, the difference between MATLAB and Octave, like I said yesterday, is not really much, and we shall be seeing some of those differences very soon. Now, the version we're using for Octave is the latest version, that's 5.2.0, and was released this month. So, MATLAB is a proprietary software, meaning that it's not free. Buy it and you install it. I wouldn't say more than that. So if you purchase the license, you want to have it. However, if you want a student version, possible in your university, you have subscribed for it, and then you can license for free, and you can use the software. In the event that that this is not available to us, we can. Octave is free because Octave is based on the GNU open source license, and you will notice I pronounce it as GNU, not GNU. Pronunciation is GNU, and it's a recursive. Anyway, you could read a lot about it on the links I've given in this slide. And by the way, for those who are interested, the slide will be available after this lecture, so you can get the slide. So, for those who were requesting for information on how to download and where to download the Octave, you can as where you can download Octave, and make sure you select. So you are using Windows, please select Windows and the particular operating system, whether it's a 32-bit system processor or 4-bit processor. For those who use Linux, if there is anybody like that, next. Now, have we Octave? We'll just quickly do it. Octave. Okay. Yeah. So at this point, let's just, if you know you're about installing Octave or you have an installer, you can just follow the steps I'm about to take on the installation. I'm going to install it from scratch, and I'll show you how it's done. It's fairly very simple. So mind you, I've downloaded it day before yesterday. So here is the installer. I'm going to wait for my screen to come up again. Yes. So I want to be sure you can all see my screen. Okay. Yeah. I don't know if you can see the installer. My mouse is right there on top of the installation file. So what you're going to do is that you click on the installation file, then you right click. You do a right click, then you click on run as administrator. Run as administrator. So when I click on run as administrator, it will ask you for a particular prompt if you were willing to install Java runtime environment. Just simply click yes. Click on yes because it's part of the libraries. Java has some libraries that Octave depends on. So you click on yes. I will explain what libraries mean later on. Then you'll be greeted with a welcome page, and on which you'll be told to click on next to continue. So just simply click yes, on rather next. Excuse me. Click on next. Then you see the license agreement. You also click on next too after reading it. Then this were the boxes I was talking about yesterday. The boxes. That's the first one talks about install for all users. The second one talks about create desktop shortcut. Then the third one is about register.m file file type with Octave. So make sure you select all these options, select them, then click on next to proceed. Then here, please, I would advise that you leave it as it is. This current window you can see now, you leave it as it is. Don't make any alterations so that Octave can install directly on your hard disk. If you alter it, you have to know what you're really doing to alter it, so that in case there's need to make modification later on, you will be able to make those modifications. But in the alternative, I advise and it's recommended that you leave this folder, what is here as it is, and just click on install. Just click install. No need to change what is here, except you deliberately want to do that. So I'll click on install, and then you wait for some minutes for it to install. So right now, Octave is being installed on my hard disk and on my system. And once it's done, once the installation is done, it will tell us it's done, to prompt us, and then we'll proceed and complete the installation process. So in the meantime, while it's being installed, let's go on to other things. Okay. Yeah. Please, are we still there?
Yes, you can continue.
So now, the installation is going on. We talked about some similarities between MATLAB and Octave, and it's important to address these concerns at this point. MATLAB and Octave are very similar. They are similar in compatibility. Like you saw yesterday, if you noticed that I talked about the extension name, that is the name that comes after a file. For example, you know that there's .exe after an executable file. For example, we also know that Microsoft Word has .doc, that's .doc. So also MATLAB has a file extension called .m, and is the same file extension that Octave uses. .m. So in terms of file extension name, you can see that they are both compatible. You can take a file from MATLAB and directly copy that file into a location in Octave and run that same file without any problems of compatibility. Now not only compatibility, there are also excuse me. Okay, yeah, sorry about that. Okay, now they are also compatible, not only in compatibility, but also in the toolbox that they use. They use similar toolboxes, which we'll be finding out later as we proceed in the course. Then in their syntax is basically all about how you write your code, how you present your code. They have similar syntax, and the interface as well is also very similar. What do I mean by interface? Interface is how your program looks like. For example, we have two kinds of interfaces. We have the command line interface, that dark screen that you are familiar with, or the blank screen that you're familiar with that you have to enter in commands. That's the command line interface. It's a point where you can interact with the computer. In other words, you can interface with the computer. Then we also have the graphical user interface, which today they just call the user interface, or they use the terminology UI. That is the colorful graphical interface that has pictures that you can click on, that has icons. Now, you'll notice that MATLAB and Octave have similar interfaces. And if you are familiar with one, you won't find it difficult to cross over to the other. Now, for those who mentioned that the interface, I'll use the normal terminology, maybe screen, that my screen was different from their own MATLAB screen. Today, I will be demonstrating how you can adjust your screen to look like my screen, so that maybe you feel it's comfortable, and then you can go on now to even customize the way you want your screen to appear. So I will be treating that and showing you how that is done. So you can also make your screen, your own interface, look like mine, or even look like the way you want it to look like. Now, Octave is a very good alternative to MATLAB, and it is completely free. Now, the installation process for the latest version of Octave is fairly easy, blah, 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 and that's what we're going through. I will check now to see if the installation has been completed, and I'll return back to the slides. Okay, well, the installation is still going on, so we'll come back to it. Now, once the installation is done, there are certain programs you can run to check if the installation is complete. And once the installation is done, we'll check them. However, there are still differences in MATLAB and Octave. On one of those differences, we will try them out today, so at least you can see that they are a bit different, even though it's quite subtle. The differences are very subtle, but they are there. And one of those differences is in the way things appear. I would like to say at this point, I would like to tell a story of how I started using MATLAB and had one or two reasons to cross over to Octave. During my research project in Masters, I had a particular problem working on the eigenvalues. I was looking for some eigenvalues to determine the modes, what we call modes, or what people may call fundamental frequency, which we know in dynamics and the rest like that, all those blah, 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 blah. I don't want to bore you with the details. So I had to create a particular solver, a method of solving the eigenvalues so that I can derive the eigenvalues for what I was looking for. And so I had to use what we call a user-defined function. I had to create my own function. And MATLAB was giving me a lot of troubles. I had to contact and talk with some people to help me out, some professors, some people even overseas. So, but eventually, when I was trying to figure out what I was going to do, someone I know who's a professor in the US actually um, introduced me to Octave. And so I said, okay, let me try out Octave and see whether the problem I'm facing of trying to get these eigenvalues and to get this solution is from MATLAB, or maybe it's probably from me. Now, mind you, when I do this calculation by hand, when I use my hand to calculate and try and come up with the eigenvalues, I really have no problem. I can find the solution, but it seemed that MATLAB didn't give me the results I wanted. So I tried doing it in Octave. That was when I discovered personally that Octave had a different way of presenting solutions. Now, the good thing about Octave was that the way it presented solutions, I don't mean to say this in a bad light, to cast bad light on MATLAB, but its presentation was somewhat similar to the way I would solve the solution by hand. Octave presented it similar to the way I would solve the solution by hand. Whereas in MATLAB, you'd have to do a little bit of rethinking, you understand, to see how the solutions really, in terms of matrix, how they appeared, from the columns, from column 1 to column 2, from row 1 to row 3. The way MATLAB will present it, may present it upside down. But Octave tends to present it just as the way you would present it if you work it by hand. However, the answers will be the same. These are some of the little differences that are involved, even though they are very, very subtle, but they are still there. Now, right before you is a program, is a short command. There are short commands that are right before you right now. I believe you can all see your screen, please. I've written here A is equal to 1. That's the first line. The first line says A is equal to 1. Then the second line says DSP. The second line says DISP into brackets A is equal to A comma blah 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 blah. Now this is this particular code or rather command in MATLAB is quite different from the way it should appear in Octave. And I will show us what I mean. Okay, now our installation is complete. As you can see in my screen, you can see on my screen rather, the installation is complete here. And okay, so I'm going to finalize the installation right now. And to do that, I only just need to click on finish. So again, the installation, the files have been copied and they've been installed. All I need to do now is to click on finish. And you will notice there's a box here saying run GNU Octave. Now I'm going to click on that. I'll make sure that box is clicked on or is checked. And then I'll click on finish to finalize the installation. And once that is done, Octave will be loaded. It will load and come up. So we'll just give it a little bit of time and the Octave screen will come up. Okay, I think it's about coming up. Okay, yes, it's on now. So we'll be going back to the slides very soon. So like I was saying, this is we've completed the installation process now, and right before our screen is Octave. So now before our screen is Octave. This is a fresh and a new installation, and you would see the way the interface is. The interface looks like, right? So let's go back to our slides. Okay. So once the installation is done, you can check to make sure that some packages are installed. Now, MATLAB comes with some packages. So also Octave, they have some packages. These packages are very important to your to the engineer or to the programmer. For example, we have packages that have to do with mathematics, that have libraries that have solved a particular solution, and you don't need to repeat those programs again or run or create those programs or reinvent the wheel, as it were. So to do that, you just need to click and just simply move to the command window. Here's the command window here, and type pkg. Pkg stands for package, and then next type list. So once you type pkg and then space list, and you hit the enter button, you should be able to see if the files have been completely installed. So I'm going to click on enter now, and it's going to bring up, yes, it shows me here the packages that have been installed, which you can see here. I'm going to scroll up. So here are the packages installed for Octave. And like I said, I'll be giving you the slide at the end of the lecture. So once again, this is the user interface. Here's the user interface for MATLAB. Basically, just how it appears. Right before me here is the editor window. We have the editor window. You can see it labeled on your screen as editor window. We also have the command window. We also have a command window here. Okay, and so we have a command window here, that's here, and we have an editor window. Now, similarly for Octave as well, we have an editor window, and we also have a command window too. So we see both of them have similarities in that regard. And if to download, here are some resources where you can visit if you want to download Octave and MATLAB, like we discussed yesterday. Now, in the aspect of the similarities, like we talked about, and the differences, let's just explore some of the differences that we can find in both MATLAB and Octave, so that we will be aware. And then in case we're going to run into any trouble, the reason is because if we're going to run into any trouble, we would have this at the back of our mind. So we'll be able to troubleshoot and debug what is really wrong with our program. So right now, I want to demonstrate something about the differences between MATLAB and Octave. Now, I have a MATLAB screen here, and I have a an Octave screen here, and I'm going to open a new file in Octave. I would explain how to do this. Now, to open a new script, you go down to the File menu, you move down to click on File and click on New Script. Alternatively, you can click on Control New. So once you are in there, you can type the following. You can type the following commands, or rather, you can type the following codes. I want to type A is equal to 1. Then I use the semicolon. A is equal to 1, like I said yesterday. The semicolon makes it a valid statement. Then now, the next line, I'm going to type display, open bracket. Then I'm going to use a square bracket. I will explain what this means later on. Then I will use double quotes and type A is equal to, then I'll end the quotes, and then I use a comma, and I type A, and then I close the square bracket, then I close the parenthesis, the other bracket. Now, once I run this particular code, I'll have to run it. I have to save this code, like I said yesterday. We save. To save, you just need to go to File menu. You go to the File menu, click on File menu, or sorry, now the File menu in the editor window, not in the main program, but the one for the editor window. Again, you're not going to click on the File menu for Octave, or rather the IDE. That's the Integrated Development Environment. This Octave environment you're seeing is an IDE, an Integrated Development Environment. But in that IDE, we have the command window, we have the command history, we have the workspace, we have the editor. Now, you're not going to click on the file of the IDE, but rather the file menu of the editor. That's the one here. You click on it, and you click on Save File As, and you save the file. We give it a name. Let's say we choose a location. And let's say I just choose, I said save it as trial 03, and I click on, I save it, I press enter. Now to run this program, I can, once again, I go to the run menu on the editor. I click on it, and then you see an option called save file and run. And I click on save file and run. Then it gives me a prompt asking me to change the directory. I click on change directory. So to change the directory, and then the program runs. Now, if you move down to the command window, you may not see it run as it were, but all you need to do is just move down to the command window. You move to the bottom of the command window. Okay. Yes, and once you click on the command window here, okay. Now you notice here that it says that in the command window, I don't know if you can all see the command window here. I'll try and bring it up so that it will be clearer. Okay. Now, you'll notice in the command window, it says A is equal to, but it doesn't give me the answer. So all I need to do is I move down. Meanwhile, the answer should be A is equal to 1. So I go back to the script and I correct the error. I made a mistake. I should have added number to string, and I will explain what this means in the lectures to come. I will explain what this means. Just take this by faith, and I will explain what this means later on. But once again, I will click on run to run the program. And you will notice here now, this time around, it does what I want and says A is equal to 1. Now, if I take this exact code I have written, and I copy it like this, I click on copy, and I move down to MATLAB to repeat the same thing I did. This is MATLAB right now. We're in MATLAB. I believe you can see it on my screen. And I right click, and I click on paste. So in other words, this is in MATLAB right now. We were in Octave. This was Octave before, right? This same exact code, I selected it. I right clicked, and I selected copy. And then I moved over to MATLAB. On a fresh editor page, I right clicked and I clicked on paste. Now you will notice here, immediately MATLAB flags my code. You will notice the squiggly lines we talked about yesterday. You notice these lines. I've highlighted it with my mouse. You notice that this one as well. You can notice this. There's a squiggly line there telling me that it does not recognize what I've written. Even though it has the same arrangement, and it recognizes, in fact, it even recognizes num, this particular keyword, num to string, and this numbers to string, change from numbers to string. It recognizes it. However, it doesn't recognize the quote that I added there. So, and if I try to save, I go to, and to do that, I go to the top menu. That's the editor menu up here. I click on save as well. I click on save option, the down arrow, and I select save as. And then I also move over to save in a particular location, the same location. Okay. Let's say I save it as trial. Don't forget, you can't run a program without saving. And then I click on save, then 04, and I press enter. Now you'll notice that here, I want to now run the program. So to run the program, I just need to click on run here and click run to run the code. So I'm moving up again to the editor window, to the editor page, rather editor menu, and I want to click on this arrow, this triangular arrow here, to click on run. This arrow is responsible for run. Now, if I click on run, it will give me some errors, which you will see now in the command window. So we're going to click on run. I click on run, and it asks me to change the folder. I change the folder. Now, if you would notice here, I'm going to expand and maximize this page. You notice it prompts me of an error, telling me that error input character is not valid in MATLAB statement or expression. So what really went wrong? What did I do wrong? What went wrong? Now, even though the program ran in Octave and should run in MATLAB, something went wrong. Now, to rectify this, all I need to do is go back to the editor and click on the editor, and then go to the double quotes. You go to the double quotes, and I change it from double quotes to single quotes. I change to single quotes. Now, notice that the squiggly lines are gone. Not only that, you notice that there was a red square here. That square is also gone. Now, if I try running this program, you'll notice it's not going to give me any error and will print out the output just as I intend. Now, I click on run, I move over to the editor window or editor menu, and I click on run. Alternatively, you can click on F5 on your keyboard. So once this is done, now check out the command window. You will discover that it writes A is equal to 1, similar to Octave. Now, what this means is this. Even though they have similarities, there are still some subtle differences that one should pay attention of. Now, I would have avoided this error if I had stuck with the convention for programming. Now, in programming convention, if you're familiar with programming languages from MATLAB to JavaScript to HTML to Python to Ruby, they have some common similarities and certain ground rules. For example, you only use double quotes when you have no alternative. The first point of call should be to use single quotes anytime you want to type a character or some words. Anytime you want to type words in programming, if you want words to appear on the display, it's preferable to use single quotes rather than double quotes. Now, there are instances where you use double quotes, but it's in order to avoid problems like we have seen here now, it's best to use single quotes. Now, if I go to Octave too, and also adjust the single quotes, like I'm here now, I'm back in Octave, and I click on the single quotes, and I remove the single quotes, the double quotes, and I use the single quotes, you will discover that the program will still run. And I click on F5 too. Now, you will see here in the command window, the program also runs successfully. So those are one of the little differences that are involved. However, it's very, very subtle. Now, back to we'll be logged out anytime soon. So once we log out, I'll log us back in so we can continue the class.
Well, it has indicated that it will log us out, but if it does, you will come back in.
Thank you, sir.
Okay.
So now back to our slides. So here, we're about delving into the nitty-gritty. Yesterday we talked about how we can perform calculations, simple calculations from simple arithmetics to complex algorithms. They are very, very possible using MATLAB and Octave. Don't forget, Octave is an alternative for those of us who are finding it challenging getting MATLAB installed. Then the installation process for MATLAB is quite time-consuming because it comes with a lot of suites, a lot of packages and plugins, and that's in that regard, MATLAB is better than Octave. For example, you have the Simulink suite, which is what we call Simulink, a very, very powerful tool, which I believe as you advance in this course, you will be able to use for your data analysis when it comes to your projects in computational fluid dynamics. If you're taking on projects of computational fluid dynamics, you will discover that MATLAB has tools that are similar to ANSYS. They may not be able to perform the way ANSYS be performed, but you can still run some analysis that can give you a pictorial representation and real-time images of how computational processes are being carried out. And now, we talked about in the slide here, we talked about that both MATLAB and Octave have similar characteristics in their syntaxes. And then we talked about the prompt. The prompt is those two greater than signs that we talked about yesterday. Then we can also perform some simple basic commands. MATLAB has certain commands that we can perform, and those commands you can perform, be rest assured, you can also repeat those commands on Octave, which I will demonstrate now. Now, we talked about here in the slide, you can see a command called CLC. And we have another command called clear here, which I'm highlighting as well. We also have another command called close here. And we have another command called close, or we have another command called ls. Ls is another a short form for list. That is list, list, to list an item. Then we also have the pwd. The pwd is the present working directory. It's a short form for present working directories. And the list goes on and on. Now, if in MATLAB, I'll move down to the window, and obviously you can see in my window here that my command window, which is this window here, currently highlighted, is quite untidy, has a lot of commands that have been written. And so if I want to make it a little bit tidy and make it, how will I put it, presentable, all I need to do is use the CLC command, which means to clear screen. CLC means clear screen. So all you need to do is simply type CLC and click on enter and press enter on your keyboard. Now you see it will clean up my screen or clear up my screen, and my screen is as good as new. Now similarly, we could have used what we call clear here. That's the CLEAR, which performs a similar function. However, clear also removes some variables. In other words, if I type something like a is equal to 1, and I press on and I click and I type press enter. Now, if I use clear, it basically you would notice there here. If I let me run that again, and then you see what I mean. Now, here I'm in the command window, and I type a is equal to 1, and I press on enter. Now, you will notice here under the workspace, if you look at the workspace, which we talked about here, that's towards your right hand side, the frame on your right hand side. You will see you see a particular, like cells in Excel. You see a particular column named name, the next column is value, the next column is minimum. Now it shows you, name tells you the name of the variable, which is A, which I just typed. And then it tells you the value that variable is holding. That is the value that is stored to that variable. That is A, as A is equals to 1. So we have A here as a variable name, and then we have 1 as the value of that variable. Now, if I go back to my command window and I click on it and I type CLC, it will just basically clear the screen. However, if I type clear, it not only clears the screen and I press enter, notice it clears also the workspace. So in other words, I do not have access to that variable again. If I want to, if I try accessing that variable by typing, I go back to my command window now, and I want to access that variable that I entered before, and I type A, and I press enter. Normally, it should give me 1 as a result. But let's see what it gives me. It tells me, notice it says undefined function or variable. Undefined function or variable simply means it has no memory of A any longer. So you will want to use clear when you are very sure you will no longer need the variables, not only one, but all the variables you have typed before now. That is the only time when you want to use clear. So you have to be cautious of when and when not to use clear. There's also another powerful command called clear all. Clear all. Now, this particular command is also another step further from clear. Not only will this command clear your workspace, it will clear the command history. Now, if you look on your left-hand side, that's the left pane, the left frame, on towards your left. clicking on that frame is called the command history. I've highlighted it right now. My mouse is over it. That frame shows you all the history of all the commands you've entered before now. So if you keep entering commands, maybe you've entered the command for years, they're all logged there. Now imagine you clicking on and typing clear all. You've cleared a backlog of commands you've had over the years or variables you've had over the years. Now it's not a big deal. It's only a big deal when you have not saved or you need those commands. So it's important that I tell us this so that we'll be familiar with the commands and know the restrictions around those commands, and so we don't end up losing valuable data. Again, the video is going to be made available for us, so we can go through the video and revisit some of those things we've discussed here today. Now, back to our slides. Rather, before we go to our slides, let's check Octave and do something similar to what we did. Now, I'm in Octave right now, and under the command window, I move down to the command window, and I click on now let me use another variable, possibly variable, and I say variable. Now notice I want to use variable xy. Now, and I say xy is equal to 13.56, and I click. And I click 13 point. Okay, yes, I can see somebody is raising up his hands.
Hello, well done, sir. Quickly, I want to ask this question. Maybe I didn't get that point because of the network from my hand here. So if I use CLC, will it also delete all what I have in the command history if I press CLC? Or it will only wipe off what I have on that command window?
Okay, yeah, thank you very much for that question. Now, like I said earlier, CLC only clears the screen. That's the command window screen. It doesn't affect your command history. Thank you for that question. Okay. It doesn't clear the command history. Neither does it also clear your workspace. Now, clear will only clear your workspace. Will clear your workspace, while clear all will clear not only your screen, it will clear your screen, clear the workspace, and clear the command history. So it's very thorough, as it were. Okay. Yeah.
Thank you. Thank you.
Now, right now, I did something here in the command window here, and I think I feel I need to bring your attention to it. In naming this particular variable, you notice that I named it xy. Now, xy is one name. It's not x and y. It's just one name. So you can name your variable xy and it's as if you named it x. Xy is just a name. So it's just like saying you name it. For example, I can even name it and say, I can say variable and say variable VA, variable like this, and name it and say is equal to 25.6. Variable is just a name. However, and we'll be seeing in a very short while, there are some restrictions to this practice. You would not want to give a name that is already available or reserved for MATLAB or Octave. There are certain reserved keywords, and we'll be delving into that in a short while. So now I have here two variables, one named xy, the other named variable. Now I can also perform CLC and it will clear screen. It will clear the screen. Now notice here in the workspace, can you see the workspace here? I'm clicking on the workspace right now. I've maximized the workspace. This is the workspace here. One minute, please. So now notice in the workspace here, there's a variable called xy. There's a variable and it has a class double. It has this and it has this, the value 13.56. So we have a variable called a here, right? And it has a value. It has a value called 1. So you see, this is the workspace here, and I can return the workspace. Okay, I've seen your charts. Okay. So now I'm putting it back now. I'm going to dock it back. Now, at this point, let me just explain. Now, notice that I am going to, okay, somebody's saying he can't hear me. I don't know. Can we all hear me, please?
Yeah, we can hear you.
Cannot hear you.
Yes, I can hear.
SA, can't hear me.
Though it's breaking, but at least I can hear from my end here.
You can hear from my, okay. Sorry about that. Don't worry. The video will be available to us. You will hear the video loud and clear. I don't know why SA's one is.
All right, sir.
And he's not muted. Oh, he said he deleted the app and is trying to download another. Okay, no problem. Okay. Don't worry. We'll try and rectify that. Sorry about that. So, like I was saying, now, back to what we were saying. Now, notice here, please, for those who wanted to adjust their screen, I'm going to do something now that may be helpful to you. Now, you will see my workspace is already separated from my Octave main window, the IDE. The IDE window is separate from the workspace. Somehow, the workspace dislodged itself from my window. I don't know how it did it. So now, to rectify this, all I need to just simply do is, okay. Sorry, excuse me. Oh, wow. Okay, yeah. So now
I think if you double click on it, that even as it has it has all those windows together. But if you double click or you press long on it and you move the cursor, it takes it out. But you can always bring it back in.
Exactly, sir. Exactly. Actually, I was yes, sir. I was trying to address one of our brother's concern. He said he can't hear me and I can't see his mic. So I was trying to see if I could help him out here. Sorry for that delay. So now, yes, just like you said, sir, I could double click on it and then it returns back to it returns back to the main window, what we call docking. It will dock back, D-O-C-K. And I can also move down to this place here. There's a small cursor, there's a small icon here that looks like a window, a small icon. And if you move your mouse there, it brings up what we call dock. It will show you dock widget. Once you click on that icon, it goes back automatically. Now you see it's back here. Notice it's back here now on my main window. It's already back and attached. It's attached back to the main window. So that's one way. So if you have it separated like that, you don't need to panic. Just look for where it's written called dock and click on dock, and automatically it will attach itself back to the main window. Just like Doctor has said. Now you can also double click on it. If I double click on it, like Doctor said, it will pop up again. And then you can double click back and then it pops back in. And you can also drag the screen. Just make sure that I would explain what that means. So back to our CLC. Once you click on CLC, right? Once you click on CLC and press enter, it clears my screen. But I can still access those variables. And to show you that I can access them, all I need to do is just to click in the command prompt. I move here and I type A, for example, now, and I press enter. Notice it gives me A again. But now, if I type clear all, if I use clear, if I say clear, I will no longer have access to A again. A would completely disappear. And that is, or rather be erased. And that's one of the things you need to pay attention to and take note of. So now back to our stuff here, back to it. Okay. Now, so we said we can also perform PWD, that's PWD, and PWD is very important. It tells you your present working directory. For example, now, if we're in Octave, and I type PWD, P, W, and D, and I press enter, you will notice that it returns a particular path, or location, an address. It tells me C .. / blah 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 blah. Now that is the path on which I am currently at, and you know that I saved the last file under a folder called test. So that's the location of where I am right now. And anything I save here, anything I do here, is all going to this particular location. So that's what PWD is. So you may need it in case you want to be sure where you are, whether you're saving in the right place or you're not, whether you're saving under my documents or whether you're not saving under my documents.
Hello, sir. It appears also that Octave saves as a MATLAB file.
Yes, sir. Yes, sir. Yes, exactly, sir.
Okay, because I saw that it was saving as a MATLAB file. Okay, no problem.
Exactly, sir. Yes. Also, thank you, sir, for that. Thank you for pointing my attention that Octave takes its files like as if it's MATLAB. So they are very like Doctor has said, they are very, very compatible. So you have no worries working in Octave and working in MATLAB. The two of them go hand in hand, and it's only in fact, there's a paper written on that, a comparative study, an article on MATLAB and Octave, and you see there the similarities between the two of them. So you have no worries using MATLAB or using Octave for your project, for your final project. Now, if you're, and then I would like to state at this point that in terms of speed, Octave may have an edge. The reason being that Octave is written in C++, and C++ is known for its speed and memory management. When you have a critical system that you're running, for example, space exploration, or maybe self-driving cars, you discover that most times people tend to want to use C++ to write their programs because it's very efficient, very fast, and very reliable. And MATLAB, on the other hand, has a bit of C, has a bit of C++, and has a bit of mainly JavaScript. I'm sorry, rather, excuse me, mainly Java, written in Java. Sorry, sir, you want to say something, sir?
What? Hello?
Yes, sir. I'm with you, sir.
Okay. I just wanted to also mention, I think there is a bit of Fortran in MATLAB also.
Exactly, sir.
And the command for MATLAB is very similar to some commands in Fortran. Though most people don't use Fortran. Again, that's what we use when we're in school. But rarely do you see packages. ANSYS also has Fortran embedded in some codes there. But I know there are other better codes that are available. And to also add again, MATLAB was actually invented to solve matrices problem. It is actually matrix laboratory. It was done at MIT, I think in the late 50s also. So it was particularly done to solve matrix problem. And they did another one, MATCAD, and that's why you still find MATLAB in MathWorks. I think they have something to do with MIT. But MATLAB is very versatile, as you also mentioned, especially with Simulink. MATLAB Simulink is, if you have any system at all that you can join together, you can put together that they affect each other, you can program them together with Simulink, and you get good results for you. So you can continue, sir.
Thank you very much, sir. Yeah, yes. Thank you for pointing that, sir. I remember watching a particular video of the creator, the man who created, the two people who created MATLAB. Like Doctor has said, they are from they were students at MIT, and like Doctor has said, a bit of history. Back then, most times the main program was Fortran. So MATLAB was in the early stages. MATLAB was written in Fortran, like exactly like as Doctor said, and that's why you find a lot of similarities between the two languages. However, in the later years, they ported to other. He also, the man who created it also mentioned it in the video that they had reasons to bring in other softwares being based on the fact that there were other softwares that were evolving and coming up, and so there was a need to revise MATLAB, and there you have it. So it has a lot of history, and like we'll see in the slides to come, MATLAB it derives its name, like Doctor has said, from Matrices laboratory, and which we'll be seeing in some slides to come. Now, thank you very much, sir, for that, sir. The now in the command prompts now, we perform some calculations. Now we have been able to know that, okay, we can add a is equal to 2, and we can do all those calculations there. Basically, what we're just doing is we are assigning variables. Now, another thing I want to point out at this stage here is this, which we'll see in this slide. Please, what I want to say now is very important. What I want to say here is what I want to say here is it cuts across all programming, almost all programming languages, well, that I know of. I stand to be corrected. So now you would notice that anytime I'm writing, or anytime you are writing, anytime anybody is writing, anytime any programmer or coder is writing, if they want to assign a variable, they'll say something like a is equal to 2, just like you have it here on your screen. The first line, second line on your screen says to create, and first line says create and assign variables. E.g., at the prompt you can type a is equal to 2. Now, why did we say a is equal to 2, not 2 is equal to a? You know, in mathematics, we know that the equality sign is how will I put it now? Is associative. In other words, you can say 2 is equal to a, and in maths it means the same thing. Now that doesn't mean the same thing in programming. I can't write, apart from the fact that I can't write 2 is equal to a, right? I can't also the variable that I want to store, that I want something to be stored in. I come again. The variable that I want to use as the storage has to be on your left-hand side. I'll take that again. The variable which you want to use to store a particular value, or to refer to a particular value later on, or you want to use as to represent a particular value or anything at all, has to be on your left-hand side. It's what we call L value in programming. L value. So you see, I said, notice that the variable is on the left-hand side of the equal sign. So you don't want to write 2 is equal to a. It will return an error because you can't assign a value to a constant. You can't say 2 is equal to a. In other words, you're telling the computer that a, which is a character, which is a letter, an alphabet, is equal to 2. The computer will have problems with that.
Hello, sir. Can I say something also? At least with Python, the equality sign, that's equals to, it does not show equality in programming, in most programs too. because it's not that A is equals to 2. It's just you are only assigning that anytime it sees A, you should print 2 or display 2. Now the equality sign, like in Python, now the equality sign is you use double equality sign to show equality. So you can say 2 plus 3 double equality sign is equals to 5. You can do that, and it will agree with you, especially when we start doing Boolean operations. But the equality sign, as you see here, it does not mean it is equals to as you have it in the. It's just assigning. It's like you see beneath that it's assigned. C is equals to A plus B. Now it says whenever you see C, show us what A plus B is. Thank you, sir.
Thank you very much, sir. That's perfect. That's perfect, sir. Thank you so much, sir. Now, now we're going to do some practical stuff here. If you're with your MATLAB and with your ANSYS, you can follow along in what we're going to do now. So moving on, we are going to see here that we've said A is equal to 1. I'm in Octave right now, and I will be using Octave and MATLAB interchangeably to let you see how compatible they are. Now, I'm in Octave, and I'm going to the command window, Now, remember, we've said A is equal to 1. Perhaps we want to assign another variable and say B is equal to 2 or 3. Now, you notice there's no space here. It doesn't really matter, but it's always good to put a space in between. That's just for readability, so that it's easily readable. It's part of best practices for programming. Now, I may not do that, but I may do that so that it's easier. Now, you notice that once I put a space in between equal to sign and 3, the code becomes clearer. However, you don't need more than one space. It doesn't mean that now, because we've said you can add space now, you now say, okay, let me even add tab. So I want it to be very clear, and then you do like something like this. It's even giving me errors already. And I say, and it's telling me that, and I say, okay, let me say I want to say B now. I say, okay, B is equal to, it's not enough. Let me add is equal to, is equal to, is equal to. No. You don't need to do that. That is no longer readability. That is something, that is something that the interpreter may even frown out and will even get us in trouble and very time soon. So you just need to just make it normal. Just say B space is equal to space 3. That's all. And then you press enter. Now, once you do that now I can also say C is equal to, like I said yesterday, space A space plus space B. And then I hit enter. Like what Doctor has said, all it just does is that, now notice, to let you know, in mathematics, we'll go and say, oh, C is equal to B. In other words, I can say A plus B. I can write it like this now in maths. Now I could have said this. I could have said, can you, I don't know, can you all see my screen, please?
Yes, sir.
Yes, sir.
You can see your screen, sir.
Now,
you can see your screen.
I wrote C is equal to space A, right? Then I said A, hold on, plus B space B. Now, what I have done now, in mathematics, I could do it another way around. And I could have written, for example, I could have said that A plus B is equal to C, which will be valid mathematically. It's a valid statement mathematically. But what you've written is going to give what we call a pass error. In other words, it won't be able to pass the value. It will be wondering, should I assign, like the doctor has said, should I assign C to A, or should I assign C to plus, or should I assign C to B? It won't know what it's going to really do. And it's basically because in programming, the way our programming works, is not built for that. It's not been written for that. It's not those things were not put into consideration. I don't know, maybe if later on, if we have quantum computing, that could be considered. But in this case, that's not possible. Now, I can't, in other words, I can't write something like A plus B is equal to C. That will be problematic. I don't know if you can see what I've written, please, everyone. While this is correct.
We cannot make our screen bigger on the phone if you are using the phone, so you can see it.
I can see it, sir.
1 minute, please. Okay. One minute, please. Okay, so what I mean is this. Sometimes, in mathematics, you can write something like this and say C, right? Okay. Okay, 1 minute, please. Okay. Okay. I'm trying to. Okay, I think maybe I would do that later. Okay. Okay, so I want to try and see if I can make it bigger. Now, if I can say something like C, I can say something like C is equals to A plus B. And I can also say something like A is equal to B plus C. Now, these statements are valid in maths. I hope this is clear enough. Okay. This is valid in mathematics, but it's not valid in programming. You can't, the second statement, this first statement here is very valid because you are assigning the variable, these two variables on your right-hand side, you are assigning them to your left-hand side. Now here, you are trying to assign C to that. A human being will understand what this means, but a computer would not understand what this means. So please don't try and write something like this. It won't mean anything to the computer. So that's just I hope we can take note of that, please. Now, because I've had that question come up to me sometime. Now, once I can do that, I am back to our screen. We have here C is equal to A. I'm writing C is equal to A plus B. And now once I press enter, it assigns the variable C, right? It assigns 4. That is, 4 is what? A represents 1 plus B, and B represents 3. And 1 plus 3 is equal to 4. And then it assigns that 4 to C. And so we have the result printed as C. As C is equals to 4. Now, this brings us to the next subject called keystrokes. There are certain keystroke commands that you can execute in the command window interface. You can execute certain keystrokes that will make life easy for you. For example, you can say things like, if you've typed a lot of things in the past and you want to recall them, you don't have to start scrolling up and down and trying to scroll. I'm the command window now. I'm trying to scroll up to what I've typed before. You may not even be able to reach out to those things. Once you know what those things are, or you're not sure of them, all you need to just do is that you go back to your command prompt, right? Please give me 1 minute. Let me just. Okay. Okay, yeah. So all you just need to do is just to go back to your command prompt and then start pressing your up or down key. So if I, for example, now I want to recall A and I don't know what value I used for A, all I just need to do is to press my up arrow key, and I'll keep pressing until I go back to where I first used A. And then once I get back to A, and it was here, right here. So this is where I used A initially. Also, if I want to find B, all I need to do is press the down arrow key, and then here's B. B is equal to A, written here. So in other words, your up arrow and your down arrow on your keyboard can help you recall previous commands that you have entered or recent commands that you have entered. Not only that, it can also help you to do what we call auto-completion. You can auto-complete. You don't need to type everything. For example, if I want to type clear and I'm not really sure, I can just use the arrow, up arrow. I can use the right arrow, and then it completes. Or I can use a tab. You can use the tab. Once you hit the tab, for example, now I'm here now. I type CL and I type E, and I'm not I don't want to type AR. I can just press the tab key, and automatically MATLAB or Octave just auto-completes the command. It also can auto-complete long list of words, and it's very helpful when you don't remember everything you've written before. It helps you auto-complete them. So now back to our what do you call it? Yeah. So we're making progress. We'll soon be through. In the next slide, back to the next slide. Now, other commands you can also run. You can run basic maths operations. For example, you could do sum, and this one is very, very helpful when you have a long list of commands or long list of. For example, you could have, like, you want to calculate the average of a particular value. You want to calculate the average. So you could just use the summation operator, and sum will just give you the value. Let me show you what I mean. If I am here back in MATLAB now, I'm going to use MATLAB for this. You can also repeat it for Octave. And I have, for example, I have maybe, let's say, scores. I want to name a variable called scores, the scores of some students. And I type scores. I don't know if you can see my screen, please. In my screen, I've typed scores at the command prompt window. I typed scores. Now, I want to see if I can. Okay, let me just move on. I'm sorry, the screen may be small, but I typed SCORES. That is score, scores of certain students. Then I open the square bracket, and I type 2. I type 3, I type 4, I type 5, I type 2 again, I type 6, 7, and so on and like that. Now notice that for each score, I separate them with a comma and with a space, or I could separate them with commas. I could say 2, 3, 4, 5. I would explain what this means later on as we go on. Then I end this by using the square bracket. Now, I could compute the average, and I press enter. So once I press enter now, you notice that it assigns all these scores to maybe probably 2/10, 3/10, 4/10, 5/10, 6/10, like that. It assigns them each of the scores of each student to the value to a variable called scores, and it stores them in that particular location. I can easily compute the average of this score by just clicking on and saying scores, right? And I say is equal to sum, right, of sum of all the sum of scores, and I open bracket, and I can compute the total score. I come back here and say total score. Now notice when I wrote total score, I did not leave any space. I wrote it as one word. Total score. That is this place. I'm highlighting this place. Total score. There is no space in between. Once you put space, it's a different thing. If you want to separate the score, you can use an underscore. Like say total underscore scores. Total underscore scores. I didn't just write and say total then space score the way I write English. That is an error in programming. Now, what I type, other programming techniques could be that you could type total and then you say capital letter for initial capital letter for S and scores. It is also valid. And you could also use numbers. However, if you want to use numbers in your naming, a variable, please ensure that you put the number after the variable, after a letter. For example, if I want to say total score, and maybe this is the third time I'm doing it, and I want to show that it's the third time, I can say 3 total. It's very dangerous to do this, and it's not recommended. So rather, I could say total, then number 3. I can write 3. I cannot write 3 afterwards. That is safe to do that. So again, I can also use total capital letter S for scores, CORS, and then is equal to, now I'm going to use sum, and then I'll put open bracket, scores, then close bracket. What I'm basically telling MATLAB to do is that I'm telling MATLAB to go into that score, pick out each of those scores, and sum all of them together. Then assign the total value, the value of that summation, into a variable named total scores. Now, if I press enter, notice that it says that total scores is equal to 29. And if you do the calculation of 22 plus 3 plus 4 plus 5 plus 2, all of them will amount to 29. Those are one of the things you could do with MATLAB. And you see, I don't have to type 2 plus 3 plus 4. All I need to do is just use total scores, and that's all. Now, you could also do what we call, you could also do a square root and find the square root of 3. And that's very possible. I will leave that for us to do at home in our leisure time. You can find the square root of 3. Find the square root of any number whatsoever. Now, we could also, we moved on to reserved key names. I mentioned this earlier, reserved names and keywords. Now, there are certain reserved names and keywords. For example, pi. This keyword is a reserved name. Is a reserved name, and in other words, it is not recommended that you use it as a name of your variable, just the same way you used A and say A is equal to 3. Then maybe probably you want to represent a particular value, then you say pi pi. Maybe, for example, maybe it's proportional integral, and you want to write proportional integral and you want to represent it in your programming for your project, and you now type pi, you're going to get an error because that PI you typed in small letter is, you can type PI in capital letter. Now, permit me to say at this point, now for a computer, in computer programming, Python, MATLAB, C++, C, Java, they are case sensitive. That is case as in C-A-S-E. They are case sensitive. In other words, capital letter A is capital letter A and not small letter A. For human beings, we know the difference between capital letter A and small letter A. But for programs, computer programs, some computer programs, you have to make a distinction between capital letter A and small letter A. In other words, when you say, please, I hope we are paying attention. I hope we're paying attention. Once you say, for example, once you say capital letter A is equal to 3, and you assign that value, and you want to refer back to A is equal to 3, and you mistakenly type A small letter as small letter, the computer would read an error or will read something different. It will not read A is equal to 3 again, because capital letter is capital letter while small letter is small letter. So if you want to type PI for pi and you use capital letter P, capital letter I, or capital letter P and small letter I, once something is different, once it's not small letter all through, then it's okay. However, again, it is still dangerous practice, and you would want to avoid this as best as possible. So,
hello, sir. Let me just say something on that quickly. Because in machine language, we only have ones and zeros. So when we write A, there is a system of 1 and 0s that it would have assigned to capital letter A, and a different ones and zeros that would have assigned to small letter A. So it's not going to read capital letter A as small letter A at all. Well, and that's why if you are writing a word, a variable that you want to assign something to, that's why I said there must be no space in between, because it will read it as two different things that you are writing. So and that's why we can't afford to make that mistake, because the machine will not read it. So the machine sees everything differently. Capital letter P is different from small letter P. The code, the binary number for capital letter P is different from the binary number for capital letter small letter P. So we cannot mix them together. Thank you, sir. You can continue.
Thank you very much, sir. Thank you for pointing that out. And like Doctor has said, you may have encountered it too. Is what we call the ASCII, ASCII codes. ASCII codes. These are codes that have been written to represent what each letter represents in terms of numbers or in terms of hexadecimals. So in terms of hexadecimals, for example, letter A is 65. His number is number 65 in ASCII code, which is short form for America Standard Code for International something. I'm not very sure about that. I could check that up. So those things really, like I said, they matter in terms of binary digits. So you don't want to name pi again as your own variable. Just reserve it and leave it for MATLAB. So also we have another word called rand. We have magic. We have all of those things. And if you are concerned and saying that I don't want to make a mistake, well, it's very simple. I have listed some documentation, a particular book you can read. It's in fact, it's very interesting. It's on MATLAB, and it's available online for free download. It's called MATLAB Premier. That's the Premier. Premier. I'll give you the slides, and you see the link, and you can download the booklet, and you could go through it, and it explains the different keywords. And in fact, another way of knowing is that once you type in a reserved keyword in MATLAB, thanks to the highlighting, what we call syntax highlighting that we talked about yesterday, that is all those colors that it adds to some text, the editor, since it's equipped to that functionality, would flag and will let you know that what you have typed is a reserved keyword. For example, if you type pi, it will change the color blue or purple in MATLAB. In Octave, it may be color red. I'm not sure about that, but it will be color red. So once you see something that was color black before, you were typing before and everything was black in black fonts, the fonts were in black, and all of a sudden you are typing pi and you are seeing color blue, then you know you need to stay clear. You need to take caution, and then you know you are typing a reserved keyword. So those are one of the few things that can help you while you're programming. So that's why an editor is very important in a programming language. Now, other operations we can perform the cosine, and we can even plot graphs. We're going to get to that, where we're going to plot graphs in MATLAB, in Octave, and we'll see how those things are performed. Now, again, I would like to show two things now, how we can use the semicolon. You know, we talked about semicolon yesterday and why it makes a statement complete. Now, a semicolon in the command window has a quite different name or different meaning from what it's used for in the editor. Now, please don't let us be confused. The editor is where you type as if you are typing normal text. It's the one that you can type everything at a go. And even if you hit enter, it will not run. It will still wait for you until you save and until you deliberately now go and click on run. That is the editor window. And you want to most times, like I said yesterday, you will be doing most of your work in the editor. But if you want to have some few things you want to quickly run, then you run down to the command window and then you do all those things. Now, if I type, there's a place for typing semicolons in the editor where you need to type semicolons to make your statement, your code complete, or else to have these squiggly lines and to flag an error. But you notice that in the command window, anytime I type something like and say something like average, for example, now average is equal to sum, right? Sum of scores now, and I say space, right? I use a backslash for division. I use the backslash. So I want to try and compute the average of those scores that we computed earlier. You know, we computed the total score, and now I want to now compute the average of the total score. I now use the same function. I say average. Excuse me. I say avg is equal to then summation. That's sum function and scores. Then I use a backslash to signify division. Then I add the number of scores that I took. That's 1, 2, 3, 4, 5, 6, 7. So we have 7 values in total. So I enter 7, right? Now, if I press enter, you know, it's going to print immediately. It's going to print the score. It's going to print the value of average on the screen. So if I press enter right now, it will show average is equal to so and so. Now, if I don't want to necessarily see the average, right? I can press the semicolon at the end of the expression. In other words, after 7, I entered semicolon, which is here, right here. And now what this does is that it will suppress the display and will not allow that display will not let the display come onto the screen. So if I hit enter now, what I'm going to see, or rather, let me remove the semicolon. I've removed the semicolon now, and I'm going to hit enter. So once I hit enter, sorry, now it's telling me that
because we didn't put it.
Yeah, I didn't put it. Thank you. So it's not going to be like a human being and say, okay, maybe because Oga didn't put S, let me just have Oga put S there. No, it's going to say you didn't put S. So I did that now, and then I'm running it again. Now, thank you very much for that. Now, you see, it displays that. Now, if I do that again, to recall the expression now, all I need to do is, I don't need to type AVG again. AVG is equal to sum. No, all I just need to do is just use the same thing we talked about earlier. I will just press my up arrow key. I'll press the up arrow key, and automatically the last expression I entered before now comes on the screen. I don't need to type again. So you have AVG as average is equal to sum, open bracket scores over 7. Now, this time around, I'm going to add the semicolon here. Then when I press enter, watch what's going to happen. It doesn't show me anything. It's as if nothing ever happened. Now, to see the value of average, all I need to do is just to type average. And then I hit enter. Then I discover that average actually has a value assigned to it. It shows me average. So that's what semicolon does. And that is why when you are writing your code, apart from being complete, if you're writing your code in your editor, back in the editor here now, right? Where I wrote A, the first line where I wrote A is equals to 1. If I remove this, A is equals to 1, then I now add I wrote A space is equal to space 1 semicolon. If I remove the semicolon, it will still run, even though it will raise an objection. But what the implication of that is that while it's running, it will also print A to the screen. Now imagine if you are doing a very large scale programming that has to do with finite elements, it has to do with Runge-Kutta, it has to do with all these numerical methods all packed together, and you have matrices of large dimensions, and you forget to put semicolon. What you're going to have is that you're going to have all those information, all those little unnecessary large scale matrices, which otherwise you don't really need to see. You don't want to see. All you need to see is just the final result. You will have all those things print out. They'll be printed out on the screen while the program is running. So if a program was to last, maybe some cases when you're doing iterations that have to last sometimes even into days, where you have to shut down your system or hibernate your system and then start it up again, and those things build up and add to the man hours, to the runtime hours that you use up, and then to also the memory space too, because the MATLAB will have to be displaying them as well. So it's helpful sometimes at this preliminary level. Now it may not make any sense, but as you advance in programming, you will need and you may want to add the semicolon. So it's always good to make it a habit to add semicolons to the end of your statements. I hope that is quite clear. Now, we're almost done. We'll soon be through with the class. Thanks for bearing with us.
Okay, back now.
Okay, are you with me, please?
Yes, you muted your.
Yeah, we can hear you. We can hear you now.
Oh, I muted.
Yes, sir.
I think I even thought okay, sorry about that.
You have muted again.
Now, I hope you can see my screen, please.
Yes, sir.
Okay.
Yes,
Yes, sir. Okay, now, so now we're getting deeper into MATLAB. Like, remember when Doctor said earlier that MATLAB derived its name from Matrix Laboratory. Now, you see here that the MATLAB itself, the heart of MATLAB, the core of MATLAB is in its ability to process large arrays and matrices. That is where it really runs superior to other programming languages. Its ability to process language. I'm telling you, if you're familiar with C++, all the things a person can take for granted in MATLAB, once you enter into Java, once you enter into C++, you will never take them for granted. You will know how difficult it is just to even define a variable. Now, don't get me wrong, those programming languages too have their advantages. For example, most times they are low-level languages. In other words, what it means is that you have some headroom. You can perform tasks way more faster, considerably faster than using an interpreter or a high-level language like MATLAB. But however, MATLAB allows your learning curve to be easy. It has a easier learning curve than other programming languages. Another very good programming language. At this point, please permit me, I would like to also say that another programming language that is very, very good, and I always advise people, Doctor can bear me witness, to always learn this programming language, is Python. As an engineer, the way the world is going, I don't see how we can escape learning Python. because every day Python is always showing to us the reason why it's becoming a force in the programming world. Most of the machine learning languages, AI, data science, they are all written, and most times written in using Python. So if you want to take on another additional language, I would advise that you go and learn Python. Now,
Yeah, let me just add to that. Python is also from MIT. And it's something that they are developing, and they've brought out that is being used for almost everything now. And they're also increasing the versatility of that language. And one of the good things about Python is you are almost like writing in English.
Thank you, sir. Yes, sir.
The syntax is almost like writing in English. All right, Andia, but you can continue, sir.
Thank you, sir, for that. Thank you, sir, for that. Very important news, sir. It's like as if you're writing in English. In fact, if you see a Python code, there are chances that you can even guess what they are trying to do by looking at by looking at the code. Thank you very much, sir, for that very important contribution, sir. Now, moving forward, it says they also employ operations. Sorry for my grammatical error there. They also employ operations and laws similar to vector and matrices in mathematics. That is why MATLAB is unique from other languages. It is built and suited to the scientist and to the engineer in mind. They had the engineer in mind when they were writing it. They had the mathematician in mind when they were writing it. So the way it's written, you can almost write, you can perform almost any kind of mathematical operation, be it vector analysis, linear algebra, continuum mechanics. You could do all those tensor analysis using MATLAB, and it's very, very, very easy compared to. So please, at this point, I would advise you, for anybody who is getting discouraged, don't be discouraged. MATLAB is the easiest programming language out there. It's the easiest that I know of, that is built for the engineer, that is built for the mathematician in mind. Anything of all the languages that is designed for the engineer, MATLAB is the simplest. And once you can move past the initial stages, it becomes easier and easier as you go. Another thing is that inside MATLAB, inside Octave, you have a wealth of information that is at your disposal. That is, their documentation is very exhaustive. In fact, with the documentation alone, you can write the software you need. I had a personal experience when writing my project too, that everything I needed in MATLAB, before I even go over to the internet, for us who don't need to go over to the internet every time and spend data and everything, you can find everything you need with examples in the documentation. All you need to do is just, let me quickly show that to you. All you need to do is to come down here. I'm in the MATLAB page now, right? Come down to MATLAB, and you move to this section, move to the top right corner, just below your minimize button, the top right corner, you see a section called documentation. Once you click in there, type anything you're looking for. If you don't understand how a matrix works, all you need to do is just type matrix there. And once you hit the enter button, you have, in fact, before you hit the enter button, you have a series. So just choose what is appropriate. It may look overwhelming at first. Just kindly take some time. Don't panic. Go through it. Read it. After a while, you begin to get how it works, and then it will become an enjoyable thing. So please don't be discouraged. It's not a difficult thing. As you go on, practice makes perfection. As you practice every day, it becomes easier. I can guarantee you that. Now, back to this. So, yeah, the same thing with Octave. You can perform operations. In fact, you can even do more operations, more technical, cumbersome operations in Octave. And Octave, on the other hand, its name, I'm sure many of us will be wondering, why did he get his name Octave? How come he came about that name Octave? Octave actually is the name, the inspiration for the name was for the creator, for the person who created Octave. I think his name is John Eaton. He had there's a particular professor he used to work with who is into chemistry and the rest and the likes. And that professor was known, his name was, his surname was Octave. And he liked that professor because he was popular for always performing very fast competition on the spot. If you meet him and approach him and say, okay, Prof, I have this particular, on the spot, he can just quickly perform on the back of an envelope. And so that was what inspired the name Octave that we have. And also, true to his name, Octave is very fast. Like I told you, is built using C++, which is a very, very fast software. So in programming language, permit me, sorry. Now, arrays, we talked about arrays. Basically, what is an array? An array is just an ordered arrangement. Now, notice I used the word ordered. An array must be ordered. It's an ordered set of numbers, or ordered list of numbers, items. Now, it's not limited to numbers alone. It can even be items. And Python has that very, very good advantage. Python can, that's why it's very, very useful in data science and keeping data. So MATLAB can do something similar, but not like Python. But in terms of numbers, MATLAB has a very, very good way of managing and processing numbers in terms of matrix, in terms of arrays. And examples of matrix is an example of an array. Vector is also an example of an array. We also have sets. We also have dictionaries, different kind of arrays. But here we're dealing with matrices, and we're dealing with vectors. You know, now, please, I would like to say at this point now, when I use the word vector, what comes to your mind is 2i plus 3j, right? Yes and no. Now, 2i plus 3j is a vector in mathematics. For example, what I mean is this. So what I mean is this. You know, a vector can be something like 2i plus 3j, right? 2i plus 3 plus j maybe is equal to maybe 3k, for example. That's a vector, right? That's true. Now you will notice that even in vector notation, you could also represent this 2i plus 3j in vectorial form. You could say something like this, 2, then, and write it like this, and say something like this, 3, or 2 and 1 here, where 2 here, this particular first 2, is tied to I, or the I-axis or the X-axis, and 1 here is tied to this one. So it's more or less as if you are just writing this in another way. So instead of writing 2, just write anything that is I must be up. So 2 is up is also synonymous to 2i. 1 is down, that is on the second row, then it's also synonymous to 2j. So it's something similar to that. Or you could even just write it in this form. You could say 2, you could say something like this, 2, then space, and say something like 1. This, what I've written here, is very similar to what is on the left-hand side here. So the only difference is that here I just wrote I, and here I wrote, so it's similar. So it's obviously there's no way of writing this in MATLAB or in any programming language and having that I appear there. So what we just do is that we use something like this. We have something like this, right? Now look at this first slide here. We say consider a row vector. This A. Are we following? A row vector. Type the following at the command prompt. What we have here is at the prompt we have A is equal to open square brackets 1 space 2 space 3 space 4. Then close bracket, close square bracket. So what I've written here is a 4-dimensional vector array. In other words, it's as good as writing A is equal to 1j 1I, 2J, 3K, 4L. It's just a way of representing. If we have a 4-dimensional array, if you also have a 3-dimensional, it will be X, it will be in the directions X, Y, Z. Now, this is very important for those who are in the field of solid mechanics, and also for those who are in computational fluid dynamics too, because you could be dealing with with flows, heat flow that is 3-dimensional in space, and there will be need for you to represent that 3 dimensions in X, Y, Z. So that's where matrices now come in, and that's what MATLAB does. Now, to write this in, I will go to Octave. Let's try it in Octave. Let's try and write that vector in Octave. So I'm in Octave right now in the command window. Now notice that I'm still working in the command window. There will be a time for us to go to the script, to the vector. I write A is equal to open bracket 1 space 2 space 3 space 4 close bracket. Now I've written, please pay attention everyone, I've written a vector, a row vector that is in row, and I hit the enter button. Now see the way it's presented in rows. That is, in this particular row 1, I've highlighted it here. I have under column 1. Now this particular column, the first column is 1. So row 1, column 1, I have 1. That same row 1, column 2, I have 2. Row 1, column 3, I have 3. Row 1, column 4, I have number 4 there. So that's an example of a row vector. Now I can also write, I hope that is clear. I don't want to rush us too much. Now, on the other hand, I can also write something like this and say, sorry about that. I can say B is equal to A. Now, notice I used quotes, A quote. A quote. It's not a mistake. Now, let's go back to Octave and see what this means. Now, in Octave here, I have A, right? Sorry, I have A here written already. Now, I'm saying B space is equal to space A. Then I'm now saying a quote. I'm not adding a quote there. I don't know if you can see that, right? Right? So now, what this means is this. I am telling MATLAB that MATLAB should, now remember I told you, the solutions of MATLAB are evaluated and added to the left-hand side. In other words, you work from right to left. And that's how it is for most programming languages. You always evaluate from right to left, not from left to right. Human beings can work from left to right and right to left. Anyhow, you can do it. But in computer programming, you evaluate what is on the right-hand side, and then you represent it by what is on the left-hand side. In other words, you assign it to the left-hand side. So, in other words, when is performing the operation, when it's operating on this, right, it's going to compute A, it will get what A is, then it will perform what we call a transpose. You know what from our knowledge of transpose, when you transpose a particular vector. If you have a vector now, for example, let me try and see if I can explain this to you.
You got my phone.
Okay, yeah. So now let me try to explain this. Now, you know, if we have a vector like this, and I say something like A is equal to open bracket 1, then comma, I say 2, right? Close bracket like this. Now you could do this again. Now the transpose of this in matrix notation would be something like, if I say A is equal to square bracket 1 and I say 2, right? Then to find the transpose, I can say something like A transpose, right? Transpose is equal to, now this time I write 1, right? Command 2. In other words, I have transposed the vector. I have transposed, so it's no longer A. In other words, the row has become the column, and the column has become the row. They've switched position. So what's in row 1, column 1 is now in row 1, column 1, row 1, column 1. But what's in row 1, column 2 now goes to row 2, column 1, which is written as 2 here. Can we all see that now? Now, okay, yeah. So that's what's going to happen now. So in a case where we have something like this, now in a case where we have something like we had here earlier, where we have something like x, for example, is equal to open bracket 1, 2, 3, 4 square close brackets. Now, once we perform a transpose as x transpose, what we're going to have is something like this now: 1, 2, 3, and 4, all in square brackets. That's what's going to happen. It's going to transpose it. So let's see how that works in MATLAB. Let's see how that works in MATLAB. Okay. So yeah, now back to Octave here. Now we have, back to what we were saying, we have B is equal to A transpose. So once I click on enter, what it does is that it transposes A and stores it in B. And this is what we have here. We have 1, 2, 3. Now this is very important, because you know, when we're doing matrix multiplication, remember the rules in matrix multiplication. What are the rules? If you want to multiply two matrices together, for you to be able to multiply two matrices together, what must be compatible? The row must be equal to the column. That's in normal matrices, matrix multiplication. I believe we are all following. We all remember from our case, Stroud, Crazy, and the rest like that. Yeah. So this is very important when we to perform matrix multiplication. So once all these basic rules are in place, once you have them at your fingertips, the reason is because you may encounter errors, and the basis of those errors may be as a result of a faulty theoretical understanding. And MATLAB will not spare us. Will not spare you. It would make sure that your maths is correct. So you may need to check up your maths, revise it. But once your maths is correct, I can fairly say that MATLAB should be able to process and compute your mathematical expressions. So now, once that is done, please notice that I've done that in Octave. That was performed in Octave. So now, in creating a matrices, matrices are a little bit different from vectors, in the sense that matrix is like a compilation of vectors, an addition of more and more vectors. And where can we apply matrices? Now, like we said, vectors can be applied in when you want to have X, Y, Z, and the rest like that. When you want to show that a fluid is moving and in three-dimensional space, like that. Now, matrices can also come in place when you want to show the stress, the shear stress against a particular vessel, maybe in a vessel that, and you want to calculate the stress of the pressure in maybe in some pressure vessels, like you may be doing in your projects too. Then you will need matrices. There's no way, you can't escape it. You're going to work with matrices. So matrices, to create a matrix in MATLAB is very easy, and it's the same as creating it in Fortran. Sir, you wanted to say something, sir?
Yes, also because we've also said it before when we did the linear numerical methods for linear equation. Many times in engineering, we come up with many equations, many sets of equations. So if you have about 200 equations, how do you solve with your hands? So you have to create a matrix for it. and then use different numerical methods to get your answers out. So a matrix is something that we cannot run away from in engineering. In any part of engineering, be it electrical, civil, any part of engineering, is something we cannot run away from.
Thank you very much, sir. Yes, I even forgot about that. That's true. When you have systems of equations, it's always handy to present them in matrices, and it makes life easy. You can easily solve, and you can find the determinants. And those determinants, they have physical values. They have physical representation in real life. For example, when if you click on Google and you're looking for words, how does Google know, and how does it return the results you want? Well, it turns out that Google uses also eigenvalues, which we know in matrices. The algorithm written for Google uses eigenvalues. So once you type in, for example, you're looking for the word maybe ball, or you're looking for football, and you type that into Google. What Google does is that it arranges all the possible hits, all the possible sites in a matrix form, and then it tries to find the eigenvalue, to find the one that best fits your search and your description, and then it returns that as the value that you're looking for. So matrices are very, 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 very useful in real life, not just in the four walls of the university. They are useful in real life. Now, here we have now, so to create a matrix, for example, now in MATLAB, the syntax is basically, you say x is equal to open bracket 1 space 2 space. I believe you cannot see the, I hope it's clear. You can see the matrix there. X. Okay, yeah. So to create this, you need all you need to do is you can say 1 space 2 space 3, then semicolon, space 4 space 5 space 6, semicolon, space 7 space 8 space 10. Now what this does is that if you are telling MATLAB that when you write 1 2 3, when it encounters a semicolon, it should move to the next row. So it will write 1, it write 2, it write 3, sorry, and then it jumps to the next row. 4 5 6, sorry, I wrote 9 there. I should have written 10 at the last column. That's column 3, 3. I should have written 3 there, and 9 and 10 there rather than 9. So it does that computation for you, and it arranges. Now, however, you could write it like this. Let me show you an example. I'm going to be using Octave again. So everything I'm doing here in Octave, you can do it in MATLAB. The reason I'm doing it in Octave is that those who are going to use Octave would not feel disadvantaged using it. You can do this. If it can be done in MATLAB, it can be done in Octave. Now, I say x, the variable x, is equal to open square bracket. Now, please notice, everybody, I'm not using, in defining a matrix, you don't use parentheses. You use square brackets. You don't use the curved brackets, the normal brackets. You use square brackets. Please take notes, everyone. Then I say 1 space 2 space 3. Now, I could have also, instead of writing 1 space 2 space 3, I can write 1 comma 2 comma 3. Please, I didn't say write 1 semicolon. Once you write semicolon, MATLAB will jump it to the next line. So if I write something like 1 semicolon 2 semicolon 3, what I'm actually saying is that 1 will be on one row, 2 will be on a new row, 3 will be on a new row, and that's not what we want. We want to create a 3 by 3 matrix. So we can say 1 comma or space 2 comma 3, and I may not need to add space in that instance again. And then when I reach the end of that particular row, I add semicolon to signify the beginning of a new row. Then I say 4 comma 5 comma 6 semicolon 7 comma 8 comma 10. Then I close my square brackets and I hit enter. Now notice, you see, it's done. It will do exactly the same thing if I had used spaces instead of comma. But you can see that we have a 3 by 3 matrix, a 3 by 3 matrix. Now, you can also perform the same thing we talked about earlier. You can perform the same thing we talked about earlier. In other words, you can add transpose, and you can transpose this particular matrix the same way you transpose it, and MATLAB will do it for you easily, the way you would have done it by hand. For example, you can say something like, we said x, right, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 10, right? Now the transpose of this x transpose in mathematics will be what? 1. What's on the roll here? What is here?
147.
Yes, yes, 1 4. Oh, okay, yes. Let me do 147, right? Abi, you have 2, 5, 8, right? And you have 3, 6, 10.
6, 10.
Right? Permit my writing, please. So once you have something like this now, that's the transpose, right? Now let's go to MATLAB and see what it does. Okay. So here we're in MATLAB right now, and Octave right now, and then I say X transpose. Now I don't write XT. Again, what's the code? What's the keyword? What's the command for transpose? Is this a quote? Yes, a quote. That's single quote. Just add a single quote there. Once you add the single quote, right, and you hit enter, it will give you the transpose. Now, I hit enter. Now notice the answer. The answer is what? It transposes it to 147, 258, 3, 6, 10. Exactly what we computed. Now, notice something, please, everybody. Please notice. It does. Once I typed X quote, it gives me this answer. This answer is not saved in the workspace. You know why? I did not assign it to a particular variable. I already just said X transpose and I said enter. So if I want to recall, if I want to refer to this variable, if I want to refer to this, I can't possibly refer to it because it doesn't stand on its own. It's an incomplete statement. It just says X transpose. What is X transpose? Is it equal to A? Is it equal to B? Is it equal to C? I don't have no idea. So if I want to store it properly, what I would do something like I can say Y is equal to X transpose, and that transpose is signified by a quote, and then I press enter. Now it tells me, now notice again, see the difference in the initial one. You see that when I just typed on only X transpose and I hit enter, it only gave me, it assigned a default value called answer. ANS is equal to answer is equal to something. That ANS answer is also a reserved keywords. It's a reserved keyword. So you don't want to use ANS in your code when you're writing your code. Please reserve it for MATLAB and for Octave. It is their reserved keyword. So if in the last instance, I now wrote Y is equal to X transpose and then hit enter. Now Y is now containing the transpose of X. So I can refer to Y later on. I can perform other operations. For example, I can tell it to find, I can find the eigenvalue of this particular equation if it has, and it will find the eigenvalue. And we'll talk about that in the future classes. That we're back to our now. We also know about matrix addition. You can also perform matrix addition in MATLAB and Octave. You can do something like X. Now, if X was a matrix, you have defined X as a matrix beforehand. Then you can also add 100. And what this does is that it will add 100 to each of those values. It will add 100 to each of those values. What do I mean by that? Well, you see that okay. So we had something like this. We had x, right? We had x is equal to we said 1, 2, 3, 4, 5, 6, 7, 8, 10, right? Now, if we are going to, if we say something like this, x plus 10 plus 100, right? What this does is that it's going to say this 100 will be added to each of these guys, each of these elements. We call them elements. Each of them, it will be added to each of them. So, and we have 100 added to 1, to 2, to 3, and so on and so forth. So we have something like 100 plus 1, that will give us 101. Then we have 102 here. We have 103. We have 104, and so on and so forth like that. So we have that there, and so let's see how we can do that in MATLAB. So when we're here, we can do something like that. You can say x is equal to x plus 100, and then you have the result. And hit enter, you get the result. Now you can also do something very interesting. And please, everybody, pay attention. You will need this one very well. If you are going to be doing finite volume, if you're going to do finite elements, you're going to be using all these numerical techniques. What I'm about to say is very, very important. You're going to need it. It's going to be very, very handy. It's going to come in very handy. This is what is called, you could also perform matrix multiplications or define a variable. What do I mean by this? Now, here in this section, this is what I want. Now, you will notice here, I said alternatively, you can use ones, you can zeros to create matrices. You can use this to create matrices. So if I use this keyword, this is a function. This zeros that you see here is a function. What this means is that these zeros, 1 is a particular function. So what this does is that it will generate zeros in that dimension that you prescribe. For example, here, if I type in the word, I say something like G is equal to zeros, open bracket, and I'll say something like 3, 3. What this does is that it will give me a matrix of zeros with the dimension in 3 rows, 3 columns. And so this is what it's going to give me, 3 rows, 3 columns. Now I can also use this to create. Now, why did I say this is very important? Doctor may want to make some additions here as well. Is that sometimes you may want to have like what I can call, maybe you have a particular set of matrices, and for each of those matrices there's a particular value that you want to assign, but you don't know what those values will be. So you can assign those values ahead of time to be 0. So when MATLAB eventually evaluates those values, what it does is that it will just add those values to the existing matrix. And this is very important. You know why? In MATLAB, you can't work with nothing. In most programming languages, you can't work with nothing. You have to have something to work with. You can't have nothing and expect to work with something. You must have a preparatory ground. So you can't just say, okay, you can't create matrices out of the blue, out of thin air. You must have pre-assigned those matrices. In other words, you have made provisions for them and defined them ahead of time. If you know you're going to be using a 3x3 matrix, you would have defined a 3x3 matrix ahead of time. Else, you'll be getting a lot of errors. So that's why we need zeros. Now, I can also have something like ones too. I can say H is equal to ones. And this will give me what? Or 3,3. Once that's 3,3, and I press enter. That's a 3 by 3 matrix of ones. You can, the list is endless. You also have other possible listings. You have random, you have magic.
Engineer, this is called the identity matrix that we use. So sometimes we need them when we are solving some problems. The identity matrix is important as much as the zero matrix too, in order to get some things on here.
Yes, sir. So it's always good to define them. And later on, maybe after this class, I will show you some of my programs. So you see where I use them, and then you have an idea of why you're going to use them and where you're going to need them. Then as you keep reading other books, you now begin to see why you need these ones and zeros, that they're not just there for fun, but they're there to make our programming easier and seamless. Now, we'll be coming to that in some lectures to come. We are about to end the lecture now, and on a final note, I'm going to just talk about matrix multiplication. For example, now we've created we've created a matrix here. We've created matrix X. Let's recall the matrix X. So all I need to do is just write X and hit enter. Remember this matrix. Now let's say I have a colon matrix. A colon matrix. Now I would like to just do a little bit of calculation for us, so we can appreciate what is really going on, what MATLAB is really doing right here. Now, so let's say we have we had our matrix again. We're going to revisit our matrix. 1, 2. We have our matrix 3, 4, 5, 6, 7, 8, 10, right? And we have another colon matrix, or a colon vector right now, and the vector is possibly let's just call it 1, 2, and 3. Now we can basically perform what we know as we can perform a matrix multiplication. For example, we can do X dot Y, and basically we call this in mathematics, we call this our inner product. We can do an inner product, right? Which is also known as the classical matrix multiplication, the multiplication of two matrices. Don't forget that for two matrices to multiply, we said that the role of the role of X must be equal to the column of Y. So
yeah, let me quickly mention something on that, because I've also mentioned it before. It will be impossible to do Y multiplied by X, because for matrix multiplication, the row of the first matrix must equal the number of columns in the second one. If you reverse it, you won't get the same answer. It may not even be possible to do the multiplication.
Exactly, sir. And the reason to add to what Doctor has said is that matrices have this probability that matrix multiplication is not commutative. You can't do this. It's dangerous. And to do this, you will need them to be square matrices for this to be possible. For this to be possible, you need them to be square matrices. So that's why I said, as you are writing your projects, you may need to revisit your case trial. Okay, sir.
Hello, sir. Yes, hello, sir. Let me also say, even when you do it, if they are not identity matrices, the answer you will get for the two will be different.
Exactly.
So if you do A times B is equals to B times A, if they both have the same number of dimensions, but the answers you will get will be different. So we need to be careful, really careful with that.
Yes, sir. Exactly. Thank you so much, sir. So this further buttresses the point that you need to let your maths be correct, and it's very simple. You don't need any problem. Just open to case trial. Case trial is very easy. Just open to the page on matrix multiplication, read it, So you will not be bewildered if you are getting results that you do not expect. And you're saying, what is going on? MATLAB is not doing this for me. MATLAB is giving me different results. I am doing this, that. These are some of the little things. A.B is not B.A. It's different. It can be equal to, I think it's equal to B transpose dot A, going if I remember my maths correctly, but it's not equal to B dot A. So we have to pay attention and get things right. Now, okay, so so now let's go back to our equation. And so when we have a and x, we want to do the multiplication. So what do? Simply do. We know we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. We have this as our x, right? And we have this as our y. So we have this as equal to, we have this as 7, 8, 10, right? And we have this here. We also have our y as 1, 2, 3. So we can perform a matrix multiplication, which simply means that you take what is on the roll here, you multiply it to this one, then you add it to the multiplication of this and this, then you add it to the multiplication of this and this. So if I would just perform the first few lines, what we're going to have is something like 1 times 1, right? And we have plus 2 times 2 plus 3 times 3. Sorry, I'm using my finger to write, so it's not going to be very clear. Okay. So this is what we have, and in other words, we have something like 1. This will give us 1 plus 4 plus 9. Am I correct? Which is going to give us something like 14. So in the first row, we'll be having something like 14. And it goes on and on like that. Then we do the next one. We take 4, and we multiply it to 1. We take 5, we multiply it to 2. We take 6. And eventually, we're going to have a column matrix or a column vector at the end of the day. We're going to have a vector at the end of the day. So in other words, a 3 by 3 matrix is reduced to a vector once it multiplies another vector, which is part of tensor notation, which is in tensor notation, but we don't need that right now. So we're expecting, what the bottom line is that we're expecting a vector right now from this multiplication. So let's see how MATLAB will do this, how we can do this in MATLAB. So we can, 1 minute please. Okay, so this is this we're in the end, at the end of the class. So let's say we have another vector. Let's define it as, I think I have y already. So now I want to, now you know that I have y already defined as a transpose of x, right? Now I want to do something. I'm going to write y is equal to the right, open bracket 1, 2, 3. Now if I press enter, if I hit enter, what this does is that it will overwrite the previous y that was there before. That one was the transpose of x. It overwrites and give it a new value, which is current value here. So if I press enter, I have a new value. Now, however, it is not arranged, it is arranged in the rows, not in column. It is arranged in rows, not in column. I will still need to modify this when I'm doing the matrix multiplication. It has arranged it in rows. So what I need to do is that I now say, to do the multiplication, I can say something like this. I can say product. I can say product is equal to x. Then I say star. Now star is the operation for multiplication. Is the operation for multiplication. I say star y, and I say hit y. Now if I press enter, there will be a problem. You know why? The row and the columns have not matched. So I'm having row 1 and I'm trying to multiply it against another row 1. There will be a problem. So I need to enter what? I need to change this y to a transpose and press the quotes. I enter the quotes. So this is now correct. So if I hit enter, in other words, again, I repeat again, I've entered product. Product is my variable. It's a name. I can name it anything. I can even call it C. Let me change it to C now so you see how flexible. I can change it from A and give it C and say it's no longer product. I name C is equal to space X asterisk Y single quotes. So in other words, this is a metric multiplication and I press enter. See what it gives me. The first answer is what? If you look at your screen, the first answer is 14, which is the answer we got when we did the matrix multiplication, if you recall. It's 14. Do you understand that now? Now,
Yes, sir.
if I had done this, okay. Now, notice if I had done, okay. Now, if I had done C is equal to, or something like this, if I had said product is equal to X star Y, that is X times Y, and I did not change Y to a transpose, to a column vector, I would have been breaking a rule in mathematics that we talked about earlier. That is, the row must be equal to, the dimension of the row must be equal to the column. And MATLAB will identify that. So if I press enter, what will happen? MATLAB will tell me error, or rather Octave will tell me error. Star, it says non-conformant arguments. Non-conformant arguments. Opt is 3 by 3 and opt is 1 by 3. So it's telling me that they are non-compatible. So that is why we talked about compatibility of the equation. It's the same thing that MATLAB will do. MATLAB will do something very similar to what is done. So let me repeat it in MATLAB and see and show you how it's going to be done too. Now you can see I'm just using the up arrow to move to the previous value of X. Then I'm going to copy the previous value of X by pressing down my shift button and selecting all the values. Now I select them, right click and copy, and I move over to MATLAB. I'm now in MATLAB window, and I go to the command window of MATLAB and right click and I click on paste. So, oh, okay, it's telling me that it's pasting everything. So, okay, anyway, what I'm going to do is this. Now, once you have troubles like that, you can.
No, I don't think it copied.
Okay.
I don't think it copied.
Okay, yeah, so he didn't copy completely. In fact, what he did was that he copied the previous ones that I don't need. Anyway, I can type it again, it's not a big deal. And I do one, and now I'm not going to use comma, I'm going to use space 2, space 3. So you can just play around with this and see how it works. Play around with it at home in your leisure time. Then I hit enter. Now I can also suppress it by using but I don't want to suppress it. Then I type Y as 1, 2, 3 and close bracket, and I hit enter. Then I do the matrix multiplication and I do the wrong one. I will do the wrong one this time around. And I say product is equal to X times that's star Y. This is not compatible. The row is not equal to the column. It should give me an error. I click enter. Obviously, it tells me error. It says error using star. Inner matrix dimensions must agree. That is, they must agree. So to correct myself, all I need to do, I don't need to type again. All I need to do, the values are still stored in my workspace. They're in my command history. Just hit your up or down arrow button. Once you hit the up or down arrow navigation button on your system, simply add a single quote at the end of Y. So I add a single quote at the end of Y, and I hit enter. Now it performs the calculation. Now notice it was a little bit slower than Octave. It could also be that I have a lot of programs on it. I have a lot of softwares on it. There are a lot. of softwares on it right now. But those subtle things, they matter. Anyway, it gives me the value, this exact same value, 14, 32, and 53, which is the same thing that I have here in Octave. So I think, let me see. Okay, let me see. Product is equal to X star Y dash enter. Yeah, exactly. Now, everybody, so you can see it's the same, exact same thing it gives me. So that's just basic thing. So we've come to the end of the class, and finally we have an assignment for us to just, it's not to harass anybody, it's just for us to get familiar. Please, it's not a compulsory assignment, but just for us to just get familiar with MATLAB a little bit. I will send you the assignments online so you can do them at your leisure, and then when next to meet, maybe probably next week, we can take them. So the assignment is that given the matrix below, compute the following matrix, that is Z is equal to X times Y. So basically, what we're telling you to do is that we want to, you know the value of your X, you know the value of your Y, and then you can perform the matrix. Now, with what Doctor has said too, you can also check out the properties of the matrix too at home and see how everything pans out. The second question says, using the matrix multiplication, this may be a little bit, this one you may need to do some little research, but the answer is right there at your fingertips. Using matrix multiplication and with a built-in inverse function. This function is called INV, open brackets, close brackets, INV, inverse function. You know, remember when I used summation too, I said SUM, sum, open bracket, close bracket. I added something inside. So now, I want to also do this and use the inverse operator. You're going to put in Y inside. And what Doctor said earlier, I want you to compute the identity matrix of this particular matrix Y. Y is equal to 2, 5, minus 1, 1, 3, 3, 2, minus 3, 5. So you can compute it with your, what do you call it? With okay, give me 1 minute, please. Okay. Okay, so are you with me, everybody? So you take your 0, 2, right? Then you have 3, you have and 1, 2 as well. So all of these things, right? This Y, remember that, everybody, remember that for your identity matrix I, it must be equal to, sorry, don't mind my writing. Y, okay, what I'll do is this. Let me go back to the.
Let them go and find out.
Okay, sir.
Then we will solve it next week. We will start from there. Let them go and find out.
Okay, sir.
That's the way they.
Yeah. Okay, sir. Okay, sir. Thank you, sir.
All right.
Okay, sir. Yes, sir. So over to you, sir.
Yeah, I think today's lesson has a very explanatory and a good introduction to matrices that we are already. So I believe from next week we will start with. We continue from where we stopped today. That continued with what the course is all about and some methods like that. And I hope we are learning. Please let us download the Octave if we don't have the MATLAB so that we can follow through. And I believe you will learn more from this exercise. All right, thank you.
Thank you very much.
Sir, someone want to ask you a question.
Okay. Question.
Hello, sir.
Yes, sir.
Hello, sir. You want
Okay,
to appreciate our engineer?
Yes, Mr. Friday, I can see you, sir.
Please. Yes. This is not Mr. Friday. This is Mr.
Okay, let Mr. Ajay finish.
Hello, sir.
Okay.
Hello, sir.
Yes, Mr. Friday, I can see you, sir.
It's Mr. Ajay.
After him, I will ask questions, sir.
Mr. Jai, please continue.
Okay, Mr. Jais. Okay, Mr.
Yes,
Jais,
sir.
continue, sir.
Please, sir, the assignment, the second one, I couldn't get it before you put it off. Please, you can help
going
us
to
to put it so I can quickly put it down.
Okay.
Don't worry, go to
All right.
assignment. The assignment page to the classroom.
Okay.
I'll send it.
Okay, my question now. In the course of the lecture, you said we can use space bar, we can use comma to separate our values. But what about in a situation where we just write it without any space bar? Will it give us error, or I need more clarification there?
Okay, yeah, very good. Now, what happens when you write it with without space bar is that it will be taken as one whole word or one single number. For example, when you do something like this and you say something like this now, right now, let me go to MATLAB so it's bigger and it's clearer. I hope it's clearer, Sha. You have something like, let's say, E is equal, no, let me not use E. Let me say, FG is equal to, open bracket, open square bracket, 1, 2, 3. Now, my intention was to say 1, 2, 3, but I didn't do that. I just said 1, 2, 3. Then I put semicolon, and I say 4, 5, 6. I add semicolon, and I say 7, 8, 9, and I end it with a close bracket. Right? I hope you can see me. Now, what it does is that if I hit enter, it will create a column vector. A column vector, right? And instead of a matrix. So if I hit enter, what you see? In other words, it takes it as if it's a number. The first one is number 123. Meanwhile, in my mind, I was saying 1 space 2 space 3, like a matrix. But it's not taken like that. It's taken like number 123. Then next one is number 456. Number 789. So that is why you need to use the space to tell MATLAB that you are creating a matrix and not just a vector.
I think we already
Thank you, sir.
I want you to try some of these things for yourself on Octave or MATLAB and see what the result is going to give you.
Okay, sir.
And that's how you keep learning more. Any other question?
Any other question, please?
Hello, sir.
Okay,
yeah.
Hello, sir. Yes.
Yes, sir.
Yes, actually, during the course of the class, I was jotting some of my questions so that I don't slow down the class.
Okay.
Hoping that the class I will ask some of them, but in the course of the lecture, we have actually treated some of them, but I think there are still 3 questions that I think I would like you to help me look into.
Okay.
So I don't have time. At first, this aspect of the bracket, I discovered that you use square brackets in some places, like on this MATLAB page that we are looking at. After you use the curved bracket and you now use the square bracket. So I actually needed you to help explain more. At what time can we use each of the brackets? Which bracket is for which?
Okay.
And the second question is the octave. When we were explaining the MATLAB,
yes,
you told us that with clear all, we can clear the work history.
Yes.
But for the octave, you didn't tell us how to clear that one.
For which one?
For the octave, if you are using the octave,
you do the same thing.
It's the same thing.
You do the same thing.
Yeah. So
then
yeah.
the third question, sir, is on my own this octave, the one I downloaded, the one you sent to us.
Okay.
I immediately opened my command page to be bold like the way you did yours the other time.
Okay.
So I was trying to minimize it. That was this morning before the class. I couldn't minimize it, and I closed the close to close it complete. Close that the command page, and I closed it. It now went off from the Octave app completely. I couldn't see it anywhere. So
Okay.
I was now looking for it. I couldn't get it, and I had to uninstall the software. So what I ask you that on such situation, what should I have done so that it's not as if one will now be using the software to do some kind of work and maybe a similar thing now install the software completely and lost a lot of files.
Okay, no problem. I'll be doing
So
that right.
those are the three questions, sir.
Oh, thank you very much. Any other person with any other question, please, before I take this. Okay. In case you have any other questions, I'll take them. Let me take this one right now. Thank you for your questions. They are very valid. Now, in the first question you mentioned, I wrote you were talking about the square brackets and the parentheses, the normal brackets we know, and when to use them. Sir?
Okay, we couldn't hear you before, but we can hear now.
Okay, sir. Okay, sir. Yes, sir. So I think the first, if I get it correctly, the first question was asking that how do I know when to use the square brackets and when to use the parentheses? Now, I want you to know that we have different kind of brackets, right? We have different kind of brackets. We have the parentheses. We have the which is this common one, which is this one. We have the square brackets, which is this one, and we have the curly brackets, or which we call curly braces. The curly braces. Now, basically, you use the initial one. That's the curly braces is used for the parenthesis is used for functions. Now, I would explain why I used it in this instance, how I used it in this particular instance here. Now, in this particular instance here, I did something like display. This is how it looks like. This is how the function actually looks like, right? So if I was in the editor window, if I have a variable like this, let's say I have a variable like this, and I have a variable, right? And I have a variable, maybe probably a is equals to 1. Now what I can do is this. Now this is we're jumping a bit right ahead of time, but let me just explain what this means. To display this particular variable on your screen, or to display it in the command prompt, right? I can do, instead of just hitting A and pressing enter, you can try this on your own. At the command prompt, this is the command prompt, right? I can type something like this to display it. I can say display. I will now pass this and say display A. So this is basically a function, right? This is a function. This is a function. And now say I will now pass A. This A, I pass it into this function. And then I type something like this and I say A. So what I've done in essence is that I have passed this variable A here into the function display, into this function called display, and MATLAB will take that A and display it on the screen. Now, without this particular display function, this function, I won't be able to display my results when I finish typing in the editor. So if I'm in the editor, for example, where this is useful is that in the command prompt, this is not a big deal. You can just press A and it will enter. But when you are in the editor, the only way to display a result, is you have to write A and is equals to 1. Even if you hit enter at this stage, it won't display. You have to type this command and say display A. Now I use to do this anytime you encounter a function, anytime you have a function, please note this. Anytime you have a function, like this, right? A function always has a parenthesis. It always has parenthesis. Now, this other one, what is called a square bracket. A square bracket is most times used, they are used for matrices. They are used for matrices and they are used for vectors. They are exclusively used for those people. So that's where you use square brackets. So now I now combined both. And the reason I combined both is that I had a particular, I had A is equals to 1. And if I just used display, if I use display like this and I say display A, what MATLAB will do is that at the prompt, MATLAB will just say, you know what MATLAB will say? When I run that equation, when you click on run, right? And click on run, MATLAB will just display 1. That's all. But I wanted MATLAB to say at the prompt, say something like this: A is equal to 1, like a human being will write. Now, this is the problem. The problem is that A here is a string, is a character, is an alphabet, is a character. Equal to is also a character. Meanwhile, numeric 1 is an integer. Is an integer, and in other words, they are not compatible. They are like oil and water, and I wanted to bring them together. So, in other words, to bring them together, I had to now, what I had to do was that I had to now use, I had to now use these square brackets to what? To concatenate. I don't know if you're with me. I had to use it to concatenate them, to bring them together. So, in other words, and then in doing that again, so I had to say something like this, display, display, open brackets, that's parentheses, then this one and this one, to bring a string, and a number together, and they are not compatible. So that's why I needed, that's the reason why I needed this one and I needed this one. So is to bring the two of them. What is a string? Is to bring a string and a number together. And even when I did that, you'll be learning to do that again. You notice that I use another function again. I said something like num to string. So what this num to string does is that it converts 1 to become a string 2. So what at the end of the day, what you're going to have is this. Don't worry, it may not look clear now, it will look clear very soon.
I want us to be fast because as we learn, you keep knowing it.
Okay, sir.
And I believe they also have a textbook on MATLAB that I sent to them also.
Yes.
So, but the explanation is quite right. You use the parentheses, the curved brackets for functions. We use the other one for numbers and to represent numbers and vectors, the square one. And then as we learn on we keep learning. There is one other question, the last one that you said, I can't remember now.
Okay,
that we can be quick, so that we can end the class as soon as possible.
Yeah. So now the last question is on Workspace. Now I will do that one, and because this question has occurred many times. So I would like to address this one. And for those who have been going through issues, I'm going to separate and in a way disorganize my workspace. So, and then I will arrange it back so we can see how it is possible to do it. I don't know if you're with me. Now, this is MATLAB right now. And this is the way my workspace looks like, right? This is the way my workspace looks like. So I can take the editor, this editor now. Everyone pay attention, everybody pay attention. This editor here, I can click on it. I'll click on the editor, the top frame of the editor. And then I would click on it and hold it down and drag it out. Do you see what I'm doing? I'm dragging it out of focus. And I keep it here. Now notice that my screen has changed. My main screen has changed. So you can see the command window is here. My command window has virtually taken up all the space. It has taken up all the space that I have. So meanwhile, I have my editor here. My editor is here. Where I'm going to type. This is my editor here. So it's different. So how do I bring the two of them together? Some people have their own like this. Now watch what I'm going to do now, everyone. This is what I'm going to do. It's very simple. All you need to do is move. I will circle a place now, right? All you need to do is move to this place here. Okay, are you with me? You just come down here. Let me make it clearer. If you can see it, please. Can you see the circle? This red circle.
Yes, sir.
Just move down there to that red circle there. Move your mouse across there, and all you now need to do is now you click on it, click on the red circle, and you see an option there called dock editor. So you click on it and then you dock your editor. Now automatically see my editor has gone back to the former place. You notice it's back where it was before. It's back where it belongs. Now sometimes it may not be there. It may now decide to my editor can go here. It can go to the side like this. I want to show you something now. Watch this now, everybody. Do you see what I just did? My editor is now side by side with the command window. That is, the command window is here. The command window is here. It's on this side.
Wait.
Okay. Can you see that circle? And my editor is here. My editor is here. So they are on different places, but they are side by side. One is here, the other one is in the other place. This one is here. Sorry. Is here. This is where my command window is. And meanwhile, this is where my editor is. My editor is here. Can you see what I just drew? My editor is on the yellow arrow, and my command window is on the red arrow. And that was not how it was before. They are now side by side. So how do I rectify this? Now, well, it's very simple. All I need to just do is now watch me, everybody. You choose the one you want. For example, I will choose the command window. Now I can choose the command window. You click on it. You click on the command window. Then you click on the top frame of the command window. That's the blue frame on the top of the command window. You click on it, you hold it down. Don't take up your hand. As you click on it, hold it down. Then drag to where you want it to be. Now I want it to be down. I want it to be down here. So I will click on it, hold it down, and pull it down. I won't release my hand until it comes down to this section here. Now it will change. Don't until you get what you want. Don't release your hand. It will keep changing and flipping and flipping and flipping until you get what you want. Don't change your hand. Just maintain your hand. And once you get what you want, release. Really, just take off your hand from the keypad, and that's all. It's back where it was. Now I will do the same thing in Octave quickly. Now Octave, normally this is how it will appear. It will appear like the same way MATLAB has appeared. The editor will be somewhere hidden over here. Okay. Okay, let me see if I can try and replicate something I did before. Okay. I want to try and see if I can put it okay. Let me see. Yes. Okay. So now I have it here. Now I can take it and add it here. Now it's separated from my main page. It's separated. So they are both of them are side by side. So I want them to be back together. Again, you come down to its own. Its own is like this. 1 minute, please. So we have this here. And then this particular section here, where I've marked as red, you click on it. You click on it. It has a dock. You click on it, and it docks immediately back to. However, it's not the way I want it to be. So I arrange it again. I arrange the window on the sidebar. I can arrange it this way. I can extend it this way too. Then I want it to be back up. It is now down. If you notice, it is down here. And I don't want it to be down. I want it to be up. So what I do is that I will go again to the editor, click on the editor here, and hold it down and drag it to where I want it to be. And that's all. Now, meanwhile, this one is already disorganized, right? So I can also minimize it and put it here, side by side. And bring the command window. Okay. And bring it under this place like this. So I can have my command window underneath here, and I can have my editor above the command window, and everything is the way I want it to be. All you just need to do is just know how to dock it. Then when you dock it, click on it and drag it and play around with it. Once you keep playing around with it, you'll be able to get it to. I hope that answers the questions that you asked.
Yes, sir. Thank you, sir.
Okay. So that will be all for now. Okay. So I will be sending the notes, and then we could do the assignments. I'll be forwarding the assignments to the.
Hello, sir. Hello, sir.
Okay.
Hello, sir.
Yes,
can we also have the recording as well alongside the notes and the assignments? The recording as well.
Yes, I will send the link to the recording.
All right. Thank you very much. Thank you.
Okay. No problem.
Thank you very much. Really appreciate it.
No problem. So next class
Thank
we'll
you,
be
sir.
moving.
Doctor, thank you too.
We've covered a lot on this class, and I know we've taken up a lot of time, but it's just because we have a long way to go. So next class we'll be going to advanced. We'll be talking about scripting and the rest, and then functions too. So we'll be delving into that in the next class. Thank you for your time. Over to you. Yes, sir. You have the floor, sir.
All right. Thank you very much. Thank you for this class today. Any questions, you can go and compile, go and try things out, and we'll meet at the next class. I'll see. I want us to hasten up so that we can start with all the numerical methods, coding them, talk about algorithms and stuff like that. So thank you again for joining the class. I hope you learned some things from today's class also. So we'll see you at the next class. Thank you very much.
Thank you very much, sir. Thank you enough. Thank you, sir.
Thank you so much for your time. We are grateful, sir. Engineer Bode, we are grateful. Thank you so much.
Thank you for your time. Thank you.
Thank you, sir. God bless
Doctor,
you.
thank you, sir.